This is a video tutorial on using the ANTARES alert broker to search and process alerts from the Zwicky Transient Facility, or ZTF. When you navigate to antares.noaalab.edu, you'll see an interface like this. Our web interface is focused on search. As with any search service, the quickest way to retrieve records is to enter a search term, in our case, an object name. For example, let's say you saw an astronomer's telegram on an interesting object from ZTF. Simply use the reported object name and paste it in the search bar. ANTARES will let you recover the full light curve constructed from the ZTF alerts. This is SN 2020 PNI, a nearby Type II supernova in UGC 9684. You can retrieve the full light curve of the source, zoom in on the plot to get a quick look of how bright it is right now. If you are interested in following up this source, ANTARES can even generate a helpful finder chart for you very quickly. You can also search by coordinates. The Cone Search interface accepts a wide range of formats for coordinates as well as a cross-matching radius. This is SN 2020 OI, a recent Type 1c supernovae. If you are just browsing ANTARES and find an interesting source like this that you might want to work on later, you can add it to your favorites by simply clicking the star. You will be able to retrieve all of your favorites at any later time by simply going to the Favorites tab on the top of the web page. Of course, sometimes we have neither a name or a position, but are interested in finding all objects that match some criteria. ANTARES makes this very easy. For example, if you are looking for young supernovae, you can look for objects where the last reported alert was within a day and the first reported alert was within the last week. You can even require a minimum number of detections to ensure that you reject spurious sources. You can also cross-match against a wide range of extragalactic catalogs. So for example, we can require a cross-match against the SDSS Galactic Catalog, as well as the NYU Catalog, or say the TUMAS Extended Source Catalog. And simply apply these filters, and ANTARES will give you a list of matching sources. We can click on any one of them and have a look at their light curves. This particular source looks like it's in a reasonably nearby galaxy, so we might expect some external data to exist on the host environment. If you are interested in retrieving that, you can click on the Symbat link. If you have a large number of objects that you'd like to monitor, it'd be very inconvenient to search for them one by one. ANTARES has you covered. You can quickly upload a CSV file of your favorite objects and monitor them. So for example, I created a short CSV of some recent supernovae. I can simply upload that file, which contains the RA, declination, a search radius, and a comment for each object, and create this into a watch list. You can even set a Slack channel to get notifications for yourself or for a group if you are a part of the ANTARES Slack workspace. You can have your phone ding every time your favorite supernova is alerted on. Use this with caution. You can see the loci within the watch list and also recover any of the loci in the search interface if they've been alerted on. Perhaps you'd like some persistence for your search, so you don't have to configure the same settings in our interface over and over. Well, you can definitely do that with ANTARES. You may have noticed that the last few objects I've shown you all have some associated tags. Tags are set for every alert that ANTARES processes using filters, algorithms that winnow the alert stream to just the objects that match your search criteria. You can simply click on tags to get a list of all of the available options that we have already. You can see the objects that pass the associated filter, and you can apply any extra selection cuts that you'd like. So for example, you can see the objects that have a tag of refit new sources SNR cut and are also associated with SDSS galaxies. like so. Creating your own tag is possible because Antares can incorporate your own custom filter into our pipeline. This is a feature that is completely unique to the Antares alert broker at present. A filter is just a bit of Python code that operates on alerts or clusters of alerts that share the same position within some tolerance. We call this a locus, but you can translate that to object if you prefer. Your filter can incorporate Python statements that operate on locus and alert properties. These are documented on the Properties tab in the Antares webpage. Every feature in the ZTF alerts has a corresponding locus property or an alert property. Typically, the locus properties are properties that are common to the entire history of the object, the light curve, whereas the alert properties refer to a single detection or non-detection on that particular light curve. You may also want to use cross-matches between loci and external catalogs in your code, say to impose a cut on redshift, or for a host to have specific colors, or if you'd like to see if something has X-ray activity. We offer a huge range of catalogs for you to use within your filter code. Example data is provided on the Antares website for each of these catalogs. All of this is available to you, and your filters are run within our pipeline with absolutely no cost to yourself. To begin developing your own filters, head to our documentation site. There, you will find instructions on developing your own filters within our sandbox environment, hosted by the Astro Data Lab. Launch a Jupyter notebook, and you'll have your own workspace, together with a repository of useful notebooks, including those for Antares development. These are hosted under Notebooks Latest, Contrib, Time Domain, which give you examples on developing Antares filters. You can use the alert and locus properties as well as the catalogs to write your own filters within Data Lab and prototype it on a random series of alerts from actual real data. Filter codes we run in Antares range from a few lines to complex neural network packages. Almost anything is possible. If you need support with packages that we do not currently have, simply get in touch with us. Once you are done with developing your own filter within the Data Lab environment, simply head back to the Antares page and then submit your filters as a new filter. An admin will approve your filter and it will begin running on the next real night of data. Antares has several other features, many of which I haven't discussed in this short video. However, on our documentation site, you can find detailed instructions and information to use the entire Antares system. I'd like to point out one last thing that you can do. Let's say you've developed your own filter and submitted it, and it's created its own tag and finding objects within the ZTF alert stream that you are interested in. Perhaps you'd like to build a pipeline around this. You can do that using the Antares Python client. This client allows you to connect to the entire Antares system without going through the web interface, simply using Python. The Python interface and client will give you a stream of JSON alerts that match your particular filter criteria or allow you to do cone searches all from within the Python environment. This lets you build really complex pipelines around Antares, and other surveys are using our alert broker for just this. We are in the process of testing Antares at LSST scale so that when the Vera Rubin Observatory starts operations, we will be ready to serve alerts to the community, you. We hope you will start using Antares and give us feedback on things that you like, things that you don't like, features that you wish we had but do not yet. Remember that we developed this alert broker not just for us to do our science, but for you to do yours as well. We together can make Antares a really critical piece of the national ecosystem for time domain astronomy.